Hello everybody! Today in this video we're going to be talking about chapter 1.2, graphs of functions. And we'll just hop into some of the examples. This says, state the domain and range of the function with the following graph. So when we're talking about domain, we're talking about left to right. Here, let me find a better color. Left and right. We're talking about sideways, horizontal. And when we're talking about the range, we're talking about up and down. And so we're talking about where does this graph, how far up does this graph go to, and how far down does this graph go to when we're talking about range. And then when we're talking about domain, we're talking about how far to the left does this go to, and how far to the right does this go to. Quickly, one thing that some people get confused on is, say you have a graph that looks like this. And we'll say it's like right here. People will think that when we're talking about domain, we are only caring about where it hits this X line right here. We actually don't care about where it hits the X line. We just want to know where does it stop and where does it start. So these are not the points where our domain starts and ends. Same for range. This is not where range hits. Range starts at the tallest point in your graph and the lowest point in your graph. So technically, let's say this is 1, and then like 0.5. Our domain for this graph would be, and actually just for fun, I'm going to make that a hollow circle. Our domain for this graph, we always start from the smallest to the largest. And if you have, it's including that point. So like say, we can see that this includes 1. We're going to do a square bracket. So we'll do, and this is -1, comma, and then we'll say, okay, what's the end point of this graph? It's right here. This is +1. However, it doesn't include it, so we're going to do a parentheses. Sometimes you will see graphs that go on forever. The domain of that graph would look like -infinity, and you would do parentheses because you can't reach infinity. You say a big number, I could give you one bigger. And then to +infinity, also with parentheses. So that's what domain is talking about. What range is talking about is how far up and down it is. So range would equal, first it will be parentheses, because we want to do the smallest first, right? The smallest point, the lowest point, and we'll say this is -1. So we'll say -1, but this is not included, and we're going to assume that's above, just for the sake of this video. Range, your graphs will be a lot more easy to tell. Range will be -1 with the parentheses, because it does not include that, and then +0.5 with a bracket, because that is included. Now, say that there isn't a point right there, and it's just a line. That's still included, because the graph is a strong line. If it was dotted, it would not be included, but that we won't need to worry about that for a little bit. Anyway, coming back to this problem, now that we know that what domain and range is, our domain is going to start at -1. So, and it's not included. There's a gap there. So -1, parentheses -1, and then comma 1, because it ends at 1. With and that's also not included, so we'll do parentheses. Range is going to be the same deal. It starts at -1, comma, and then goes to +3. Parentheses for both. Now this one is a little bit different. It's the same principles, but this time we have one open circle and one closed circle. So our domain, it looks like our graph starts at -1, and it is not included because there's an open circle there. And then it looks like it ends at +3, and it is included there, so we'll do a bracket. And then for the range, it looks like the lowest point is -6, and that's included, and the highest point is 3. And that's also included because there's no hole in our graph that shows otherwise. So this would be the answer for this problem. Now this one is saying find the x and y intercepts on the graph below and enter your answers as ordered pairs. So what we're saying when we want the y intercepts, so this is our y-axis, and this is our, this is our x-axis. And when we're saying we want x-intercepts, we want to say, where on this line does x hit? And it will be 1, so -1. And I think you might want curly brackets. I haven't checked. If you get it wrong, try getting rid of the curly brackets and then resubmitting your answer. And it wants it as ordered pairs. So one of our x-axes is -1, 0, comma, and then another coordinate pair with parentheses around it, 1, 0, comma, and then 2, 0. And then you close it with a curly bracket. I don't remember if this actually needs a curly bracket or not. If you're getting this wrong and you double check your points and it's still wrong, get rid of the curly brackets. Sometimes Lumen is really annoying. Every time Lumen is really annoying. And then for the y-intercept, it's basically the same idea, just for the y-axis. And it looks like there's only one y-intercept here, and it would be right here at 2. So we'll say 0, 2. And then end that. Okay, now we're saying consider the following graph. How many turning points does this graph have? And when we're talking about turning points, I'm assuming it means like right here is a turning point, right here is a turning point, because it's changing the direction of our graph. So I would assume 2. If you're getting that wrong, maybe it counts like this is a turning point, this is a turning point, and this is a turning point. So you could try 3. I think that it should be 2 though, because we're only thinking about this. I don't remember what Lumen wants for that. And then the global maximum. So when we're talking about maxes and mins, let me choose a better color for that. That's not a better color. Maxes and mins. It's about the same. It's pretty self-descriptive. When we're talking, so there's 2 different kinds. So there's local maxes and local mins. And there's global maxes and global mins. When we're talking about local maxes, we're saying, okay, so we know we have our high point up here. However, we also have a high point here where it turns, and and then for local mins, we have a low point here, but we also have one here. So we're talking about these points here. Our global, so that's for local max, and this one is only asking for global maximums and global minimums. So our global maximum, it looks like it goes on to infinity. So we'll do infinity. And then the global minimum, it looks like it goes down to negative infinity. We can assume that graph continues. Yeah. So now we can use what we learned just barely and say, and it's saying, consider the graph of the function below. Does the graph have a local minimum or a local maximum? And it looks like it has a local minimum because right here is what we're thinking. And some of them will ask for the point. I think I have some examples of that. This one doesn't. You just have to pick. What is the equation for the line of symmetry for the graph above? When we're talking about lines of symmetries, we're basically thinking of like a butterfly, right? What is the point where you can flip it over and have the exact same pattern? So like, in the case of this graph, it looks like if we put a line right here, I didn't draw that very well, right here, and then you flip the graph over, it looks like it will be symmetrical. So now we need to find the equation of this line. When you have something going straight up and straight down, you know it's going to be an x equals, because all of these x values are 3. This x value is 3, this x value is 3. So x equals 3, no matter the y value. So we can get rid of all of the y's. There's only one y. And then we know it's not a -3 because it's right here. And we know it's not a -4. We know it's not a 4 because that doesn't look symmetrical. It's just going to be x equals 3. Now this one's saying, determine the horizontal and vertical asymptotes of the graphed function. When we're thinking about horizontal asymptotes, we know horizontal is sideways, right? And we know vertical is up and down. Now, we just discussed what makes a vertical line. That is x equals something. And in contrast, we can imagine that a horizontal line is going to be y equals something. So in this case, it looks like our vertical, because all of our y values are going to be -1 in this case. We're looking at the dotted red lines. So our horizontal, because this is horizontal, our horizontal asymptote, and asymptotes are places where the graph cannot exist because it raises an error. So our horizontal asymptote looks like it's going to be y equals -1. And you do want it to be written as an equation like this, y equals -1. I'm fairly sure. I think you will get it wrong if you do just -1. And then in this case, we think it's -2. So x equals -2, because that's vertical. Whoops. And then for the last problem, it's telling us to state the intersection points of the two functions on the graph. It's a little bit hard to see, but it looks like it hits here and here. So our intersection points are going to be -2, 1. I don't believe it matters which one you put in which. And then -3, 2. And you might be confused why I'm using normal parentheses. It's because we're talking about coordinate pairs and not domain and range or inclusion or exclusion. We're just saying, where does it intersect? Okay, yeah, that covers this video. If you have any questions, please let me know. Have a good one.